Okay. So I know I told you guys to go to the page 2, but I wanted to point out that we're going to be getting to this, all right? So here we have a little flow chart, and you're going to have to be able to do this stuff right here, right? So you're going to have to be able to figure out how to name something by using the flow chart. So the first question says, what type of bond does it have? So what are you guys going to ask yourself initially in order to figure out if it's ionic or covalent? Okay, but how can you tell that by just looking at a formula or reading a name? So me saying barium chloride versus carbon dioxide.
Where is that on the periodic table?
But why? Because what are we going to ask ourselves? Does it have a metal? All right, so ask or put this right there next to it.
You said page 2.
I know, I'm sorry, I lied. Does it have, I changed my mind. Does it have a metal?
Yeah.
Oh, goodness. All right. Okay. And then once you figure that out, now we see that ionic things get named a little bit differently than what covalent things get named. All right. And so that's what we have to look forward to. The other thing that we want to kind of start paying attention to is that not only are we going to have the valence electrons, that's what we're going to pay attention to today, is our valence electrons. So does everybody have a periodic table that has your valence electrons on it?
Yes.
Are you sure?
No.
That didn't sound very positive from all y'all. But you guys wrote them on your little periodic tables. Okay? And if you didn't, what you can do is you can add it to this little segment right here. So you see that these all have little charges on them, right? So we can go ahead and write for valence electrons, because that's what you need today. We're going to go ahead and say 1 for group 1. We have 2 for group 2. Group 13 has 3. Group 14 has 4. 15 has 5. 6, 7, 8. Those are your valence electrons. So that's the part that you guys need today. Okay, because we're going to start with electron dot notation. Electron dot notations, by the way, were the ones that people were still struggling with on last week with the test, where you had to go dot, 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 like twice, right? So just, we're going to use that. All right, so you have this to refer to as I'm asking you for the valence electrons. All clear? All right, now we can go to the actual page 2. My apologies. All right, let's write these in real fast. So a metallic bond forms between a metal and another metal. Metals hold their electrons very loose. Okay? Valence electrons are allowed to flow in a, what are we going to put right there? What did we put on the very first page to always remember about metallic bonding?
Let's go to the first page.
What did we write about metallic compounds? What did we write about metallic compounds, you guys? What did you say? I heard you say it. The sea of electrons. All right. So that's what we're dealing with here. So they're allowed to flow in a sea of electrons. Do you guys remember I showed you the little video clip that showed them not attached to their atom, right? They're kind of they're playing hot potato the whole time. Okay? All right. And then finally it says, this explains why metals are good conductors. All right. So that's cool. But we're going to put that to the side because we're going to talk about ionic stuff again. So ionic stuff are ones that contain a metal. So I've already written in half these notes for you, so please read along with me. Okay. So an ionic bond forms between a metal and a nonmetal, or a positive and a negative ion. In an ionic bond, electrons are transferred from the metal to the nonmetal. Metals will lose electrons, right? Why?
Because they lose a positive.
No, but why does this side want to just get rid of their electrons?
Because they're giving it to their dad. They don't want them anymore.
Yeah, okay, so they don't have very many, so it's easier to just get rid of it to move backwards than it is to try to gain 8 electrons, right? So that's one of the reasons. The other one had to do with electronegativity values. Remember, who's our least electronegative guy on our periodic table?
For oxygen.
Francium. Yeah, this corner, right? So they're the furthest away, so they get rid of theirs really easily. So metals will lose their electrons to form positive ions or cations. Nonmetals will gain them to form negative ions, anions. A positive ion and a negative ion attract, right? Opposites attract, like things repel. And this creates an ionic bond. An ionic compound can also be called a salt. We wrote that on their front page as well. When you dissolve an ionic compound in water, it can conduct electricity because the ions separate and are free to move around. That's why covalent don't do that. They don't have a metal. Okay? All right. So now we're going to run through this. So I already kind of gave you an example down here. So we're going to look at one and then we'll try one on our own. Okay. So when you are drawing out what happens with an ionic bond, we're showing the actual transfer of an electron. Okay. So we first have to start with drawing the Lewis dot diagrams. That's the electron dot notation, by the way. So we put the dots in order. We're going to say our valence electrons, right? So I'm going to be asking you that in a second. You guys ready? No? Well, get ready. All right. Then you have to show the transfer of electrons with an arrow. Then you're going to write down the resulting ions and number of each ion as the subscript. What is a subscript? What's a subscript, you guys? In 6th grade. They're the little numbers. They're the little numbers. So if I put like CO2, it's that little number. Right? It's a subscript, not a superscript. Superscripts are up high. Subscripts are down low. All right. So,
Like the two.
yes. So if we have NaCl right here, okay? We first have to start. You can ignore the electron configuration. All that's dealing with is it's just showing you where those electrons, the valence electrons, came from. Where are valence electrons, by the way, in an atom? The outer side, yeah, the outside, right? The outermost shell. So sodium. Sodium is in group 1 on your periodic table. So how many valence electrons does sodium have? 1. So we would draw sodium and we would put the dot up top. Chlorine was in group 17. So how many valence electrons does chlorine have? 7. So we went 1, 2, 3, 4, 5, 6, 7. Do you guys see that? Okay, so we would have drawn our Lewis dot diagrams. Now we show the transfer. So if you notice, I drew an arrow going from my metal to my nonmetal. We drew that arrow right there. So now look at the next picture. I have sodium. Are there any dots around them? Can somebody tell me why?
Wait, where is sodium?
No, why doesn't this sodium have any dots around it, you guys?
Oh, because it's the one before.
It's got stolen.
So like if it's
So
like,
he
Took it.
he transferred it, right? Isn't that what this arrow means? He took his little electron. He said, here you go, chlorine. It's all yours. Okay? So he gave it to chlorine. So he doesn't have any more. Because he lost one negativity, he became positive. Chlorine, on the other hand, has how many dots? 8, because he took the electron, right? So 1, 2, 3, 4, 5, 6, 7, 8. Because he took an electron, he took a negativity, he became -1. The last step that we do is we count up how many of these we have, and we put them there. Did I write any ones? Did I write any ones in this formula? No, and in chemistry, you really don't write ones, okay? All right, so let's try one together because you guys are, I'm losing y'all. All right. So let's look at something like, let's do potassium and fluorine down here for the practice. And then we'll come back up and we'll look at this one over here. All right, so potassium and fluorine. I need to know valence electrons of potassium.
1.
Potassium is in group 1, so he has 1 valence electron. So we're going to say K, and we're going to put a dot above him. Fluorine, where's fluorine at?
Oh, 7.
He's group 17, so he has 7. So we're going to put an F, and we're going to go 1, 2, 3, 4, 5, 6, 7. We have to show the transfer. So we're going to draw the arrow from fluorine to potassium or from potassium to fluorine. Good. Start at the metal, go to the nonmetal. So do you see that he has an extra one? He needs one, so he's going to give it to him. Okay? So our next step is we're going to write it in brackets. a K. Do we put any dots around it? No, because it's showing me after, right? This is before, during the transfer, after. He doesn't have any more dots around him, so what is its charge since it gave away an electron? A positive what, though? Positive 1. Fluorine has how many dots around it now? 1, 2, 3, 4, 5, 6, 7, 8. So fluorine gained that electron. So he gained one negative thing. So what is his charge now? A negative 1. Now you have to count up how many of each you have. I have 1 potassium. I have 1 fluorine. So we're just going to put it together like that. And there's your formula. Okay. So now let's do one a little bit trickier. Let's do the magnesium and the iodine. So number 2. Okay. So magnesium is in group 2. Magnesium is in group 2. So how many does he have? 2. So we're going to say magnesium. We're going to go 1, 2. How many does iodine have?
7.
Good. 1, 2, 3, 4, 5, 6, 7. Okay. So what's the next step? What do we have to do, you guys? So he's gonna get. So he's like, okay, well I have 2 extras, so here's 1, right? But is magnesium happy yet? No, he still has 1 more, right? But does he have anywhere to put that? No. So we have to draw another iodine. So please draw another iodine so that you have a place for that electron to go. And we're going to draw an arrow going to that new iodine. So this right here is very key to how we're writing our formulas, just so you know. They have to fit together like a puzzle piece. Magnesium isn't just going to donate one of his electrons. He's like, no, that doesn't do anything for me, right? He has to donate both of them. So he just needed another iodine in that situation. So with that, now we're going to write out that we have magnesium. He lost 2 electrons. Be careful. What is the charge if he lost 2? Not -2. He lost the 2 electrons. It's positive 2. What about each of those iodines? They each gained 1. So they both have a -1. Sorry, I'm speeding up because I'm about to lose you guys. So we have that. We have to count these up. How many magnesiums do I have? Nope, this one. How many do I have right here? I have 1. So we're going to say magnesium. How many iodines do I have listed? I have 2. So we're going to put I with a little 2. Okay. Okay, so we will pick up on this again tomorrow, but I need you to come back ready to do this. All right? Yes.
Already ready for Friday.